cells, cancer, okay, it has a very high rate of blood flow. Think about this. Think about its location to the pituitary gland, and then think about the control we need. Because if it plays a part in metabolism, what is the definition of metabolism? Do you happen to know the definition?
Is it the sum of all metabolic activity?
Yes. Hopefully, in part 1, your professor taught you that metabolism is the sum of all chemical reactions in the body. What do we mean by chemical reactions?
Something being broken down.
Something might need to be broken down, such as foodstuffs. If we break stuff down, what else do we have to do? Build stuff, i.e. proteins, cell membranes. We need to carry out cell division, okay? So, the hormones, we have T4, T3, about 90% of what comes from the thyroid gland. Now remember, the hypothalamus has to tell the anterior pituitary about this hormone. One of the other things that can happen with the thyroid gland is it can help self-regulate, meaning stimulate to make more, inhibit to make less. So that under normal conditions, we're keeping a certain level in the blood. That doesn't always happen, but under negative feedback, that's what we hope is going to happen. So, T3, T4, if you tend to have this particular problem with the thyroid, hypo, or something else, when you go to the doctor, they'll usually draw blood and they'll check for this. They'll usually check for both T3 and T4 because there are certain levels that should exist in the blood. So, the calorogenic effect, this means, first of all, it helps with oxygen consumption. How does our body use oxygen? What process occurs at the cellular level to use oxygen? Breathing? What's another term for breathing? Alex?
Respiration.
Our cellular respiration, which produces what?
ATP.
ATP. That is how our body uses oxygen. So it's going to help with that, making the energy of the cells. Now, the other part about the thyroid gland. The thyroid gland, the makeup of it, it's going to have what we call follicles. They look like little sacs, okay? Those contain a protein-rich colloid. Do you happen to remember what a colloid is? A colloid is where we have substance, and the particles get to keep their structure. The other makeup of this gland is our follicular cells. So that follicle, the cells that surround it, parafollicular, okay, around the follicle, those are going to be secreting thyroid hormone. Now, the cells, we've got the follicles that help with thyroid hormone. These parafollicular cells, their job, pay attention to the calcium in the blood. Why? Why do I need to watch out for calcium levels in the blood? What, huh? Okay, calcium we tend to associate with our bones. What two major processes do we use calcium for? Nerve cell conduction and muscle contraction. Without it, this can't take place. One of the things about our bodies, the calcium level is not allowed to waver much at all. In other words, we have a set number for the calcium level that should be present, and as long as the body can, it is not going to allow it to go very high or very low. The shift in it is very minor. So the goal, control calcium levels closely. Now, and remember, I'm not an artist, okay? So don't y'all laugh, all right? A bone, okay? Y'all can laugh. Now, when we think of bone, we think of that as storing our calcium, right? All right? Yes, this is true because the part of the bone that is hardened, if you remember from part 1, is calcium, the hydroxyapatite. Do y'all remember that? The calcium and the phosphate? Okay. So, if we take in our calcium in our diet and everything is nice and good and healthy, hopefully the part of the body that needs it will use it. What's left over, we'll store, okay, keeping our bones strong, all right? And then if the body needs some calcium, it can help, you can break down that bone a little bit, release some calcium into the blood. Once it has enough, the calcium gets stored back in the bone. Do y'all remember the cells that exist in bone? What are they? Okay.
I don't know if it's right. Are you talking about the bone marrow?
Do you remember what the term is for bone? Osteo. And do you remember the types of cells that were present? We have osteocyte, osteoblast, which one breaks it down? Gabrielle? There are two more actually, but we tend to focus on three. Do you remember? Clasped. Let me explain how this works. Should have learned this in part one, hopefully. Blast are the immature cell. They're the ones that release the hydroxyapatite and as they release it, they get stuck in the lacuna. Does everybody remember that? When it gets stuck in the lacuna, it becomes a mature cell known as a site. Osteoclasts come along and break the bone down. Does everybody remember that? Okay, because this is a process in our skeletal system that takes place 24/7, 365, 366 if it's a leap year. You are constantly breaking down your bone and building it back up. Over the course of a lifespan, normal lifespan, like 70, whatever they have as the predictions now from male to female, okay, you will replace your skeletal system at least 7 times. Everybody knows that, right? Yes. It's a constant remodeling that takes place for your skeletal system. Y'all didn't learn that in part one? It is so cool. Go back. Do y'all have access to my part one videos? You do, Alex. It is so cool. I'll try. Anyway, it is so cool, the process that happens with your skeletal system. Okay? Now, in the case of this thyroid gland trying to maintain calcium levels, all right, what it will do, it'll secrete calcitonin. So, those little cells that are around and in between follicles in our thyroid gland, okay, calcitonin is going to pay attention to calcium levels, all right? And so if we get a message that says there is too much calcium in the blood because osteoblasts lay down hydroxyapatite. So therefore, if we have too much calcium, we need to store it. And that's what it'll do. It will say, osteoblast, get busy and lay down this calcium into the bone. So my thyroid gland, okay, for my thyroid gland, okay, because you're going to see why I'm pointing this out. My thyroid gland wants to help store extra calcium that's in the blood. Why? If I have too much calcium flying around in the blood, and if calcium is important in nerve conduction and muscle contraction, if I don't control that, what will it do to those two processes? It will affect the function. Do I really want the function of my nerves or my muscles to not function? I don't either. Okay? So this is a way to help us keep control over that. Did you ever know that?